In this session, we'll be taking a look at Chapter 8 objectives. We'll solve absolute value equations and absolute value inequalities. First, we'll take a look at the formulas. And the first formula is the formula for an absolute value equation. And it states that if you have the absolute value of x is equal to some value a, then you want to solve x is equal to a or x is equal to negative a. Our next formula is for the absolute value less than or less than equal to absolute value inequality. And it states that if the absolute value of x is less than a, then you want to solve negative a is less than x is less than positive a. This formula works for both less than, and if you're given a less than equal to, that equal to will simply follow in the formula. We're given the next formula for the absolute value greater than or the absolute value greater than or equal to, and it states that if x is the absolute value of x is greater than a, then you want to solve x is less than negative a or x is greater than a positive a. If you're given a greater than or equal to inequality, your equal to bar will follow in your formula. Let's take a look at the first example. Here we're asked to solve the absolute value equation, the absolute value of m plus 2 is equal to 26. First, we'll isolate for our absolute value, so we'll subtract 2 from both sides of our equation. So we have the absolute value of m plus 2 is equal to 24. Now we'll use our formula and we'll drop the absolute value. We'll set it equal to a positive, or we'll drop our absolute value and set it equal to a negative. And now we'll solve both of our equations for m. So for our first equation, we'll subtract 2, so m is equal to 22, or in our second equation, once again, we'll subtract 2. So m is equal to 22 or a negative 26. Next, we have the absolute value equation. The absolute value of 7 minus 5x divided by 2 is equal to 20. Here our absolute value has already been isolated, so we'll simply apply the formula. So we'll drop the absolute value. We'll set it equal to a positive. We'll drop the absolute value and set it equal to a negative. So now we'll solve both equations for x. So the first thing we'll do is subtract 7 from both sides. Next, we'll divide both sides by 2. And now we'll divide by negative 5. So we have x is equal to negative 26 over 5. We'll solve our next equation for x. We'll subtract 7. We'll multiply both sides by 2. We'll divide by negative 5. And we have x is equal to negative 26 over 5 or 54 over 5. Next, we'll solve the equation, the absolute value. So we'll drop our absolute value and we'll set our problem equal to a positive. And then we'll drop our absolute value and set our equation equal to a negative. The first thing we'll do is distribute our positive and get rid of our parentheses. Next, we'll solve for x, so we'll subtract x from both sides, and we'll subtract 4 from both sides. We'll divide both sides by 12, so x is equal to negative 11/12. For our next equation, we'll distribute the negative to get rid of our parentheses. Now we'll add x to both sides and subtract 4. We'll divide by 14. So we have x is equal to either negative 11/12 or 3/14. Next, we'll solve the absolute value less than inequality. So our formula says that we will set it up as a -6 is less than or equal to 8x minus 5 is less than or equal to a +6. This is a compound inequality, so we'll work it from the inside out and we'll isolate x within our inequalities. So first we'll add 5 to all 3 sides. Next, we'll divide by 8. And we'll write our answer in interval notation. So we have the closed interval from -1/8 to +11/8. And for our last equation, we have an absolute value greater than. We have the absolute value of 8y minus 5 is greater than 6. So we'll apply our formula. So we'll remove our absolute value. We'll reverse the inequality and set it equal to a negative. Or we'll drop our absolute value, keep the inequality given, and keep our value as given. We'll solve our first equation for y, so we'll add 5 to both sides. We'll divide by 8. So y is less than -1/8. For our second equation, we'll add 5. We'll divide by 8. Y is greater than 11/8. So now we'll graph and we'll find the union of sets. So I'll draw a graph. I'll center it at -1/8 and 11/8. We'll put negative infinity to the left, positive infinity to the right. We want all numbers that are less than -1/8. So there's a parenthesis at -1/8 that faces the left. Our line extends toward the left. Or we want all values for y that are greater than 11/8. So at 11/8 we have a parenthesis that faces the right. Our line extends toward the right. So our interval notation solution is the half open interval from -infinity to -1/8, or union the open interval from 11/8 to +infinity.